In this lecture, we want to find the orthogonality conditions for the time-dependent Schrodinger equation. In order to find the orthogonality condition, we must know that what is the definition for the orthogonality. Orthogonality and orthonormal system, as we have read it in calculus. What is orthogonality and what is calculus? Actually, a mini statement. You can say that calculus is applicable in quantum mechanics. So in calculus we have read that integral of any two variables, just like x dot y, integral of xy is with respect to dx or dy. If it is equal to, suppose we have just like two sequence a n and a m are two functions. Two functions are said to be orthogonal if their integral is equal to 0 and if their integral is equal to minus infinity to infinity. The limit is minus infinity to infinity, and if the value of the integral is 1, then we say that that system or that functions are orthonormal. So orthogonality conditions, for orthogonality conditions here, we want to find the orthogonality on wave functions. Since psi is wave functions, so we will take two functions, just like we can take psi n and psi m. So integral of psi m or psi n from minus infinity to infinity should be equal to 0. If this condition is satisfied, we say that the wave function in Schrodinger wave equation satisfy the time-dependent Schrodinger wave equation satisfy the orthogonality conditions. Also, we will check the orthonormal. Either the wave functions are orthonormal or not. Let me start. Here I am taking two functions. Function of x, and actually functions over here are wave functions. Let the first is psi m and second is psi n. These are two functions, wave functions. So let these two wave functions be the two non-degenerate solution or eigenfunctions of time-independent Schrodinger wave equation. Then corresponding Schrodinger wave equations, we know that what is it? It is minus h cut square divided by 2m into partial square psi m into x divided by partial x square, okay, plus v of x into psi m of x is equal to E m and psi m of x, and this is 1. Okay, and for psi n it will be minus h cut square divided by 2m partial square psi n of x divided by partial x square plus v of x into psi n of x is equal to E n psi n of x, and this is 2. Okay. So forming complex conjugate of equation 1, we will take the complex conjugate of equation 1, and when we take the complex conjugate of equation 1, we get it is minus h cut square divided by 2m partial square psi m of x partial x square. Okay, complex conjugate. So here we use the steric steric mean complex conjugate of equation 1 plus v of x and psi steric m of x, okay, is equal to em psi m steric of x. And suppose this equation is 3. Okay, now we multiply equation 2 by psi m steric and equation 3 by psi n. Okay, we are multiplying 2 by psi m steric. This is the equation 2. We are multiplying over here by psi m steric, all the equation. So it will be minus h cut square divided by 2m psi m steric partial square psi n of x partial x square plus v of x psi m steric of x psi n of x is equal to en and psi m steric and of x psi n of x. Okay, and we multiply equation 3 by psi n only. This is equation 3 multiplied by psi n minus h cut square divided by 2m, so psi n partial square psi m steric mean complex conjugate partial x square plus v of x, and this is psi n of x psi m steric of x is equal to em, and this is psi n and of x and psi m steric of x. Okay, so now these are two equations. It is equation 3 and this is equation 4. Okay, now we subtract equation 5 from 4. Okay, when we subtract equation 5 from 4, then check it. After subtracting these two equations, minus will be plus and this is 4 and this is 5. Minus plus minus, this is plus, so it will be minus. Okay, so when we write these equations, so from here h cut square over 2m is common, h cut square divided by 2m is common, then we write psi n. I am writing first positive, since this is a positive term, psi n partial square psi m steric divided by partial x square. Okay, and since this is negative, and we can write it just like minus psi m steric partial square divided by partial x square. Okay, and in the next term, these two psi m steric, psi n steric, this will be cancelled because one term is positive and the second term is negative. And the next here it is En minus is equal to En minus Em into psi m steric and psi n of x. Psi m steric and psi n steric. Okay, now h cot square divided by 2m. I'm writing this equation on the next. It will be psi n and partial square psi m steric of x divided by partial x square minus psi m steric partial square psi n of x divided by partial x square. Okay, and h cot square divided by 2m. On the other hand side, 2m divided by h cot square, and this is En minus Em. Okay, En minus Em and psi m steric of x and psi n of x. Okay, now we write just like it is. I'm writing this term first. So psi m steric partial square psi partial square psi n of x divided by partial x square. Okay, minus psi n partial square psi m steric of x divided by partial x square, and this is equal to 2m divided by h cot square. Since we interchange and the negative term we write first, here we also change En minus A. It is just like we write first Em minus En psi m steric of x psi n of x. So now we add and subtract. We are adding and subtracting partial psi n divided by partial x and partial psi steric divided by partial x on left hand side. Here okay, divide and add and subtract. Therefore this side will be psi m steric partial square psi n of x divided by partial x square minus psi n partial square psi m steric of x divided by partial x square. Add this term plus partial psi n divided by partial x partial psi n steric divided by partial x, and now subtract partial psi n divided by partial x and partial psi n steric divided by partial x is equal to 2m divided by h cot square and this is em minus en psi m steric and psi n of x. Now we write first these two terms which are positive terms. It is psi m steric partial square psi n of x divided by partial x square plus partial psi n partial psi n and m, partial psi n, and this is partial psi m and this is m, okay, plus partial psi m steric partial x partial x, okay. Now these two terms, taking minus common from these two terms, it will be psi n partial square psi m steric of x divided by partial x square, okay. Now take common the this term and this term, okay. It is plus partial psi n of x divided by partial x partial psi m steric of x divided by partial x, which is equal to 2m divided by h cut square e m minus psi m star of x okay. Now after adding this can be written as, it will be partial over partial x into psi m steric partial psi n divided by partial x, because these two terms are actually the derivative of, partial derivative of these two factors with respect to x. Minus, similarly here we write partial over partial x and here psi n and partial psi m divided by partial x m steric, because these two factors because these two terms are actually the derivative of, partial derivative of these two factors with respect to x, okay. So this is equal to 2m divided by h cut square into em minus en into psi m steric and psi n of x, okay. Now integrate with respect to x minus infinity to infinity. When we integrate, since derivative is the opposite of integration, after integration, okay, this derivative will be cancelled out with integration, okay. And here minus infinity, remember that we are taking derivative minus taking integral from minus infinity to plus infinity. So here we get psi m steric partial psi n divided by partial x minus psi n partial psi n steric divided by partial x.